In this video, learning the Kennedy's theorem with the plane motion. Now, the theorem states that any three bodies having plane motion will be having plane motion related to each other will be having three instantaneous centers, and all those three instantaneous centers will lie on the same line. Now, these are the two criteria we need to prove here. One is all the three instantaneous centers lie on the same line, and there are three instantaneous centers. These two things needs to be satisfied here. Referring the diagram now, these are the three bodies. One is the body A, second is body B, and the last is body C here. Now, all these A, B and C will be located parallel to each other. All these three bodies are not coinciding. They are located in three planes. Let's say assume plane 1, this is plane 2, and this is plane 3. All the three bodies are stacked one above the other, so that you will be when you view this all three bodies from the top, you will be viewing the diagram like this one. Now, there are two criteria to be satisfied, proved here is they have three instantaneous centers. To satisfy to prove this one, using the formula to find out the number of instantaneous centers. Now, you know the general formula, the standard formula is this one. Capital N equals n into n minus 1 by 2, where capital N represents the instantaneous centers and small n represents the number of links or bodies here. Now, from the diagram, since we have considered three bodies here, body A, B and C, small n, the value of small n will be 3 here. Now, substituting the small n in this formula, we will be having capital N equals 3. Now, this represents there are three instantaneous centers. So, we have satisfied the first condition here. So, the instantaneous center. Second thing there is all these three instantaneous centers lie on the same line here. Now, to satisfy this one or to prove this one, we will be assuming three quantities here. Now, first is IAB, that is nothing but this is general representation to represent the instantaneous center between body A and body B, and IAC is nothing but instantaneous center between body A and body C, and IBC is nothing but instantaneous center between body B and body C here. Now, these are the three instantaneous centers here. Now, from the geometrical this thing, we have made that the IAB and IAC to locate on the same straight line. And to prove the second condition of the theorem, what we do is we will be locating this IBC, instant center between the body B and body C, will be located apart from this straight line. It will be represented above this straight line. We will not be making it to lie on the same, we will be not making it collinear with IAB and IAC. Now, what is while writing the conclusion for this one, first let's assume this the instantaneous center IBC to be located on the body B here. Now, when this instantaneous center IBC is located on the body B, it will be having a velocity component VBC, which is perpendicular to the line joining IBC and IAB. Now, this is the first condition. We will be assuming this IBC to be on the body B, so that it will be having a velocity component VBC that will be perpendicular to the line joining IAB and IBC. Okay. Now, this is the velocity component. Second condition, what we will be doing, we will be assuming this IBC now to be locating on the, it will be located on the body C. We will be assuming this one. Now, when this instantaneous center is located on the body C, it will be having the velocity component VBC, this vector line will be located perpendicular to the line joining IBC and IAC. Now, since we have assumed this instantaneous center IBC in the first case to be located on the body B, and in the second case to be located on the body C, we have here two velocity components which where the directions are different here. Okay, the directions are different. Now, recalling the definition of instantaneous center, what it says, any point which is common to the two bodies. Now, this is the common point, there is nothing but instantaneous center between body B and body C here. Now, at that point, the velocity component, its magnitude and direction should be same as per the definition. Now, since we have assumed this IBC to be not collinear with IAC and IAB, we have moved this point to be slightly above this particular line. When this point is moved or it is not collinear with these two existing instantaneous center, it is having two different velocity components. Now, according to definition, this is not possible. Hence, what is the conclusion? All the three instantaneous centers, it lies on the same line. When all the three instantaneous center lies on the same line, the velocity component will not be of these two types. All the velocity components will be equal. Now, this satisfies the second condition. So, first we have proved that there are three instantaneous centers by using the formula, and second is we have assumed that this IBC to be located in the first case on the body B, and in the second conclusion we have assumed it to be lying in the body C, so that when this instantaneous located on these two bodies, it will be having two separate velocity components, which is actually not possible as per the principle of plane motion. Hence we will be saying that all the three instantaneous centers will be lying on the same straight line. This is the Kennedy's theorem.